Hello everyone, let's solve this question. This is also module based question. In here they have given this circuit which is carry select adder. Okay. So in the last video we solved question based on the ripple carry adder, and there is one drawback while using this ripple carry adder. We need to wait carry out from this first adder which is going to the second 16-bit adder. In the last video we saw that. So to resolve that issue we can use this carry select adder. So in this carry select adder, what will happen here? First adder is same, okay, but C out of the first adder is going through this mux, and we will check both condition. Means if C out will 0, then also we will check, and C out is 1. This C out will be 1, then also we will check. So both condition we will check, and based on the C out, this mux will pass the result. Okay. So in this way we can resolve that issue, ripple carry adder drawback, and we can use this carry select adder. Okay. So let's solve this question. So here C out of this first adder is going into this mux as an input. Okay. So we need to declare this one as a wire. Here also this sum 15 down 0 is going through this mux. So here also this pin is acting like a wire, and this pin is also acting like a wire. So we need to declare 3 wires. Here C out is 1 bit wire, and these two, this one and this one, these two is 16-bit wires. Okay, so we need to take care of that. Let's solve it. Wire. Here this wire I will write as a selection. So ACL. Next wire, this is a 1 bit wire. Okay, selection is 1 bit wire, and next these two are the 16-bit wire. So wire 15 down 0 W1 comma W2. Okay, so both W1 and W2 are the 16-bit wires. Next, same here, this add 16 module has given already, so we can instantiate this module. Okay, no need to write a code for this 16-bit header. So let's solve it. Add 16, instance name u1. Next, here we can use by positioning method. So first a 15 down 0, b 15 down 0, comma b 15 down 0. Next C in is 0 here, so write 0, 1 tick b 0. Next here sum out and C out. Okay, so sum 15 down 0 and C out is here, this one is C out, and here C out is, we declare wire, right, that is selection, ACL. So ACL. Okay, done. Next we need to use these two adders. Okay, so write the code for those adders. Add 16 u2, same here a 31 down 16, because in the second adders we are passing remaining dates. Okay, so 31 down 16 we are passing through these two adders. 31 down 16. Next b 31 down 16. Next C in, here C in is 0, and in the second adder C in is 1. Okay, so in the first we will write 0, 1 tick B 0. Next, here sum is this wire. Okay, so what we wrote, W1. Okay, so we can directly write W1 here, W1. Okay, next, here cout we can ignore. Okay, so I will keep 0. 1 tick B 0. Okay, next, same I will just copy here. Instance name is u3. These a b are same, and here cin is 1. We call this one. Okay, so initially for this first adder we kept cin is 0. Now we will keep this cin is 1. Okay, both condition will check. If 0 will come means this will go, and if 1 will come means this will go. Okay, next, here wire is w2 because this wire. Okay, and cout is 0. Okay, now we need to write the code for this mux here. So in the last video also we wrote code for this mux. In the same way we can write here. We can use the always block, always at the rate asterisk, then begin end, and within this begin end we can write code. So here we can use the case statement, case and case. Okay, here based on selection output will come out. Okay, based on selection, so based on this pin, selection means this pin. Okay, so if selection is 0 means this will go as output, if selection is 1 means this will go as output. This is the working principle of this mux. Okay, so let's write here for 0 what will come here. It's a 31 down 16, sum 31 down 16, sum 31 down 16. Okay, so non-blocking assignment, what will come here, w1, right? Yeah, w1, so w1. Next, for 1 sum 31 down 16, same non-blocking assignment, w2. Okay, for 0 w1 will go, and for 1 w2 will go. Okay, so this is the code for this mux. Let's check if this solution is it correct or not. Okay, so while writing this code I did some mistakes, so that's why I got one error. We just correct those things. Some bracket I by mistakenly I added. Okay, we just once again check it this code, and now this code has run successfully. Okay, so in this way we can solve this module instantiation based question. One more question is there. Try to solve that question. This question. So try to solve this question, and if you face any problem then just comment it. We will try to solve this question, but initially you just try this one. So in the next video we will solve some other topic questions, like in the next topic is procedural, so we will solve these questions. Okay, so try to solve this one in. Okay, and again we will meet in the next video. Till that, thank you.